Hello everyone, welcome to Principles of Communication Systems Laboratory. The subject code is PEC 402 and it is IPCC Lab. This is Professor Jaslin from ATME College of Engineering, Mysuru. According to the IPCC syllabus of Principles of Communication Systems, Experiment 3 is amplitude modulation and demodulation. That is to generate and display relevant signals and their spectrums for understanding amplitude modulation and demodulation process. Before moving on to write a code, let us know what is modulation. Modulation is the process of varying a carrier signal property that has amplitude, frequency or phase according to the message or information signal, and the purpose of modulation is to enable the efficient transmission of information over long distance through different media and with better resistance to noise, and the opposite of modulation is demodulation. Now let us generate the signal in Scilab. So this is the code written on Scilab to generate the modulated and demodulated amplitude signal. So CLC stands for clearing the console window. Then FM is message signal frequency, that is 3. So you can define whatever you want to, and FC is carrier frequency, that should be greater than FM always, and sampling frequency is 100, and T, the time period is 0 to 3 between the interval 1 by Fs, and P is the length of the time duration. Then AM stands for message signal amplitude and AC stands for carrier signal amplitude. Once you execute the code, then you have to enter manually the AM value and AC value. Now first we need to generate message signal. To generate message signal, the equation is message is equal to AM into cos 2 pi FM into T. The value of AM, FM and T is defined above. Then figure 1, the subplot 3, 1, 1, meaning there are 3 rows, 1 column, and in first grid the message signal is plotted. Plot T, message with x-axis labeled as time, y-axis amplitude and title as message signal. Now we need to generate carrier signal. The equation to generate carrier signal is AC into cos 2 pi FCT. Again AC, FC and T values are defined initially. Then subplot 3, 1, 2, meaning there are 3 rows and 1 column, and in the second grid the carrier signal is plotted with a plot T, carrier. So this Ka is amplitude sensitivity of the modulator, which is defined as 1 by AC. Then mu is modulation index, which is Ka into AM. So display this mu and name it as the modulation index. Next, amplitude modulation generation, that is to generate the modulated signal AM mod is 1 plus Ka into message signal, and dot star is element wise multiplication. Then subplot 3, 1, 3 is there are 3 rows, 1 column, and the third grid amplitude modulation signal is displayed with plot T, AM mod. So to generate the frequency spectrum of the message modulated signal, D is equal to minus P by 2 to plus P by 2 minus 1 in steps of 1 and multiplied by a factor 1 by 3. So again it is plotted in a different window with 2 rows, 1 column, and in first grid the frequency spectrum is plotted. The time domain, to convert the signal from time domain to frequency domain, we use fast Fourier transform. We apply fast Fourier transform, and it is labeled as X label frequency and Y axis as amplitude and title as AM signal spectrum. Now to generate the demodulated signal of the modulated signal, we use D mod is equal to AM mod and multiplication with carrier signal. Then K is again constant value. Then filter 1 and zeros. Then subplot 2, 1, 2, meaning there are 2 rows, 1 column, and in the second grid the demodulated signal is produced. and plot t comma IFFT, that is inverse Fourier transform, is applied to see the demodulated signal. So in the demodulated signal we need to see the original message signal. Now and save and execute. So go to the console window where I have to enter the message signal amplitude, enter 3 for example, then enter the carrier signal amplitude, enter 4 and click on enter. So you see two windows appearing on the screen. So this is actual message signal, that is baseband signal, and this is the carrier signal, and this is the amplitude modulated signal at the receiver, and this is amplitude modulated signal spectrum, which is represented in frequency domain. So at the receiver we perform demodulation to get back the original message signal. The message signal at the modulation and the message signal at the demodulation should match. Thank you.